And I think we're ready to go. Good morning, good afternoon, wherever you are watching this virtual tech meetup. It's my great pleasure today to be introducing Ben Holmes, who's going to be doing a talk on Vite projects and using Vitest. And before we dive into our presentation, I just want to do a quick mention and a quick word from our sponsors. So this is brought to you today by LogRocket. I'm sure the vast majority of you today will be tuning in, having seen us from our blog. You may not know that we actually have a great product for production monitoring for your front-end applications. So LogRocket combines error tracking, performance monitoring, infrastructure monitoring, and web analytics. It's all rolled into one solution, so all of your teams can have a single source of truth. It allows for more efficient remediation of your problems and iteration of your feature sets. And in addition to this, it also can plug in quite comfortably with your existing backend monitoring tools. So if you'd like more information, you can head over to logrocket.com and you can get a personalized demo. You can sign up for a free account and just get a sense of what it can do for you. I would like to also point your attention in the direction of a meetup that we have next week, which is React Accessibility Essentials for Developers. It's going to be presented by Catherine Nans, who's a fantastic developer, and that'll be next week on December 15th at 12 p.m. Eastern time. So if you would like to sign up to that, you can follow the URL, or you can just type LogRocket meetups and it'll be the first thing that comes up on Google. Now, with all of that out of the way, I'd like to welcome Ben to deliver his presentation and take it away. Thank you.
All right, awesome. Thanks for that intro, and also excited that there's more accessibility talks popping up. It feels like it's a growing topic every year. But I will go ahead and share my screen here as we get going. So first off, little intro about me. If you don't know, my name is Ben Holmes. I'm known as B Holmes Dev everywhere. I should probably type that out, a little personal plug. But I am currently a core maintainer over at astro.build, which is a framework for building very performant sites and even full stack apps. And I'm also what I would call a whiteboard educator. I don't know, but I have a running like Twitter and YouTube series where I break down concepts on the web in video form, just 1-minute bites about everything you might want to learn, including Vite, which I've done a series on in the past and we'll get into today. But we'll get a little taste of whiteboard stuff in a moment as well. wtw.dev if you want to check that out. And I'm a music lover, so if you're ever in New York City and want to, join me for a concert or something like that, hit me up. I know LCD Sound System was amazing. If there's any fans for that out there. So you can see here I have some pretty scrappy slides put together. I'm using Obsidian for this. It's just my go-to if I want to throw together a little presentation. But to start us off, I'm going to talk a little bit about what Vite and Vitest are, what those terms should mean to you. And we'll also talk about Vitest versus Jest, which is the most comparable testing framework out there, to understand their inner workings and why Vitest might be more performant for some situations. And then we'll actually build a thing. I'll send you a full link so that you can follow along. And we will code up some tests, both for backend endpoints as well as a front-end UI using React testing library. So to jump into what Vite and Vitest are, I like using this analogy from the original iPhone presentation, where he does this grand reveal of the iPhone is an iPod, a phone, and an internet communication device. An iPod, a phone, are you getting it? Because the iPhone is this conglomeration of all these features that used to be these split out tools that you had to stitch together yourself. And Vite is very much that for the web. It's an all-in-one solution to bring together all of the tools and frameworks that you might need in order to build a website. Let me zoom in a little bit here. So first off, it is a JavaScript bundler. If you've used Webpack or something like that in the past, or you've used Rollup on its own, Vite includes that out of the box. So it's going to use Rollup and ESBuild in order to build your websites as performantly as possible. But it also includes its own dev server. So instead of setting up, a separate framework like Next.js or setting up a browser sync process that points to Webpack, you get a dev server out of the box that Vite's going to run for you and listen for file changes. And it also includes full-on asset management. So if you have a style sheet with a link tag in your HTML file, you want to transform that with Sass, Vite is going to do all of that out of the box so that you don't even have to set that up. And this is why I'd say Vite sort of thinks about bundling differently, where the HTML files that you write are the true entry point to all of the stuff that it does. So instead of pointing it to a main.js file and having a big array of those that you keep track of, it's going to crawl all the resources used on the page. So link tags, script tags, image tags, whatever you want it to look at. And it's going to figure out what to bundle and when. And the beauty of that is it can leave resources unbundled while you're working in development. And how is that possible? Well, since import statements are something that is now supported in browsers today. If you didn't know, you can use the word import inside of a regular old script tag in Google Chrome or Firefox. Since that exists, it can leave your project unbundled while you're working so that when you edit an individual file or an individual component, it's able to rebundle just that component on the fly and then leave the rest of the site untouched. So you get this really fast hot reloading, or HMR as it's called, where while you're working, it's only going to reload the resources that really matter. It's going to save the work of bundling for the production process. And why am I talking about Vite when Vitest is the focus of this talk? Well, Vitest straps onto this bundling system and brings all of that goodness to your tests. So first off, if you're using a Vite-based framework right now, a running shortlist is Astro, SvelteKit, Nuxt v3, and other frameworks coming soon like SolidStart. If you're using any of those, then Vitest will strap onto whatever build process you already have and have the same amazing hot module reloading while you're working on your tests. So the same way that we unbundle your resources in the browser, you can unbundle your resources during tests so that if you just edit one little React component, it can rerun all of the tests for that React component really quickly. It's only going to bundle the component that changed. And this also means minimal config. So first off, if you're using Vite already in your setup, there's literally no config to write for your tests because it's just going to reuse whatever's in Vite. And if you're even coming from like a really heavy Webpack process and you want something a bit simpler, well, Vite plugins are a much simpler model that you can try out. So that's the real thing that I want to take away from Vitest is that it's really fast feedback loops when you're rerunning your test and development, and it has really minimal config when you're setting it up for the first time. So now I want to compare Vitest and Jest so that we get a better baseline of where the Vitest benefits lie. And you own a whiteboard. Oh, I do own a whiteboard. Okay. Well, let me jump over here. Stop sharing my screen if you don't mind focusing my video. But on this whiteboard back here, let's go ahead and explore Jest versus Vitest. And I got an extension cable so I can do this. So let's try this out. So you see up here, I just wrote their logos on the board. So we have a little baseline. But to compare the two, I would start with a test file that you might be writing in order to test a UI in your project. So let's say we wrote a test in Jest, or a test that we want Jest to run. And we're going to just draw a little arrow to represent that. And inside of here, ooh, this marker's not too good. Let me switch over to the blue one. Let's say we wrote a test file that we want Jest to run, and that test is a test.tsx. So it's going to test maybe a React component using React testing library in order to see if it renders out a certain result. And in order to run that test, we have to teach Jest how to process a React component because it doesn't know anything out of the box. Jest is a very unopinionated test runner. So if we wanted to run this, we would need to set up a build process that Jest is able to run. And their out-of-the-box guides that are very tried and true are setting up a Webpack process or setting up a Babel process. They also do have a guide for Vite, but they themselves claim it doesn't work super well. It's very experimental. So you're probably sticking with Babel and Webpack if you're using this framework. And with that, if you're using their getting started guide, you might go down the route of setting up a Babel preset env, which is the default that most people reach for. You also might need Babel TypeScript in order to run all of your TypeScript. You might have Babel React or whatever the name of that plugin is these days. All of the plugins that you need in order to process TypeScript, process import statements, process React components, all of that wired up. And when it runs through that transform process, it's going to output a very nice common JS module that we can run through the test runner. And this is an important point, that we're compiling to common JS when we're using Jest. And that's firstly because Jest is from sort of an older guild of running tests, where in Node, if you ever wanted to import a resource, if you're writing a Node server, you would need to use the require syntax in order to do that. So you would say require dependency and then use it in your application. But these days, browsers support a more modern import syntax, which I've been hinting at up until now. You know the one where you say import X from Y. It's the only thing that TypeScript supports, so you've probably used import X from Y at some point. And this is a newer standard that Jest unfortunately doesn't support out of the box. There is an experimental modules flag that you can use with Jest specifically, and this will point it to sort of more recent versions of Node, but it is still marked as experimental. Your mileage still may vary. So if you're using Jest with all of the recommendations on our docs today, you're probably going TSX file, bunch of babble, get it to CommonJS, run my test. Now let's compare that process to Vitest. So in Vite, you would probably write a test file much the same way. You can use a TSX file, tell Vitest to process it. And in order to bundle, instead of setting up your own or bringing your own bundler, Vitest will use Vite in order to bundle all your resources. So Vitest is opinionated in that way, where you are going to use Vite whether you like it or not, but you're going to like it, I can guarantee. So if we process it with Vite, instead of using Babel processes by hand, you're probably going to reach for a plugin that is recommended by the ecosystem. The React Vite plugin is one of the popular ones, but if you have rollup plugins already in your project, you're able to bring those and use them as is as well. So React is actually going to do some Babel stuff under the hood, but it does have some options if you want to use a Rust-based compiler. That's still emerging. But this is going to be a bit less config to do the same thing. And then in order to run it, instead of processing to CommonJS, it's actually going to process to sort of a framework agnostic test runner that could be run in either CommonJS or ESM. But the beauty of that is if you are using ESM imports in your project, which you probably are, like if you're writing a React component, you're using import syntax to grab some other resources, it can take that build result, turn it into regular ESM, and just use normal import statements. And that unlocks the fast reload that you're probably looking for. So to give a little example of like, well, what is the benefit of doing it this way over this way? Well, first I'll say, if you're doing a regular production build, there's not really any difference between Jest and Vitest. If you just run it end to end in your CI, you do a one and done approach, it's going to run through this transform about as quickly as it's going to run through this transform. They'll finish in the same amount of time. The real difference comes in while you're in development and you're hot swapping resources to test what's going wrong. So an example that I'll give here is maybe a hamburger. If you know me, you know that I always reach for the hamburger jokes, mostly because I'm hungry all the time. So I'm going to make a bun component, perhaps, that inside of it renders a tomato. It renders maybe a meat patty or something like that. And then we'll close the bun off here. Maybe you could use some lettuce as well, but you know, we're keeping it simple. So let's say that we're trying to test that this component here renders out a perfect hamburger. They integrate well together. Well, in order to test that with Jest, you might do your initial test run and it will give you the result of whatever the hamburger rendered out. And now let's say while we have it in watch mode, we edit one of the component dependencies. So I change tomato over to some pickles, for example. And we want to assert that this change in ingredients doesn't change, you know, whatever we're trying to test about this hamburger. So if we change it over to pickles, Jest is going to say, all right, a dependency of this test file changed. I'm going to toss it over to Babel to figure out what might have changed. And if you just have the default setup, it's probably going to throw away the whole hamburger and just rebundle it top to bottom. So we're going to throw out the old one. We're going to make a new hamburger with pickles this time. Then we're going to pass that whole result through the test runner all the way down. So if you make a change, it's going to take about as long on the second pass as it is on the first pass. But in Vitest, since we have access to the Vite bundler and we understand what's going on, it's able to be just a bit smarter about what rebuilds. So when we swapped out tomatoes for pickles, Vite has an import map of every little dependency that changed along the way, and it doesn't need to bundle them in order to know what changed. So if we edit pickles, it's going to smartly say, all right, you didn't change the whole hamburger. You just changed pickles. So I'm going to swap out one ingredient for the other, leave the rest of your component unchanged, and then run that through the transform process again. And with that, you can get a much faster reload time, where this might take 500 milliseconds to run through the pipeline. And this result only takes like 50 milliseconds, because instead of rebundling the whole universe, it just rebundled the resource that changed. So that is the first major benefit they're going to get out of Vitest. And of course, you can get something kind of similar in Jest if you understand Webpack-isms. But if you're going through a getting started guide like I did, you're probably going to end up with much better performance over here. And the second bit, of course, is that our config got a lot simpler in the process. We used some best practices that we probably didn't need to edit. We're just using React to make a thing, and we're going to run it through the pipeline as efficiently as possible. So with all of that groundwork laid out, I'll leave a little pause here if anyone wants to ask some questions, and then we can jump into a demo. So I'll leave a few moments of air for that. There we go. All right, I'll double check the chat. I don't see anything in here. But if you have any questions, speak now. And if not, I'm happy to answer them at the end of the talk as well. All right, if not, then we can move on to actually using Jest and Vitest to do something. So let me go ahead and share my screen again in order to see what's going on here. Desktop 1, that will do. So we've explored the inner workings a bit. Now let's go build a thing. I have a link here if anyone wants to follow along. I'll go ahead and share that in the chat. But this is going to be a starter project that is running both a Netlify serverless function, as well as a React app that is going to query that function. And you can see here, this is based on Jay Langsdorff's Egghead course on doing this stuff. So if you want to learn how this app was built, I would definitely recommend going and checking out that little course over here. But we're just here to test the app. We're not here to build the app. So we're not going to go too much into those details. But let me open up the chat while I'm sharing my screen. Always a challenge. I will share that here I don't know if I can share with everyone, but I'll at least put it in the chat if we can share it out at the end. But if you go to my Ben Holmes dev profile on GitHub, you'll find this with this big word dump, React, Netlify serverless, etc. So we're going to do a few things here. We're going to set up Jest from scratch. We're going to write a test for our endpoint. We're going to write a test for React. And then we're going to see how Vitest compares, if there's much difference, how the production build times fare, and if our diagram back here actually matches up with what we're seeing. I do have a chat message. Oh, okay. Sharing it out again for everyone. Cool. So let's jump into a code demo. So I have that repo pulled up here, and I have the starter branch pulled up on the side, and this just has some code stripped out for us to write it live. But if you go to the main branch, that's going to have all the solutions to what we're working on right now. And I set this up with a source folder, which is just a standard React app. We have a Netlify folder with all of our functions. And we have a test folder that's divided between Vitest and Jest. Because we're trying to compare both, we've set it up to run both. And I also have some utils to save us some time. This is just going to mock some stuff for our server. And this is going to query to make sure our form is on the page and give us all the elements on the page so we can test them. So first, let me run the app so we at least know what this thing is, what we're working with. Run Netlify dev. In here, we should see it's a serverless app, rendered with both React and Netlify. And it's a very simple app. It just asks for your name and your favorite hex code, and it will shoot it back to you if it is properly formatted. So here I'm just going to say, my name is Ben. And my favorite hex code is, I've been using CCC as demo, but I realized that is not a very cool hex code. Let me go with, I heard that Kent C. Dodds has a name that actually works as a hex code if we do that. Dods. Yeah, check that out. C Dods. So if we send that away, we get, hey, my name is Ben. My favorite color is this, and we get some logs that tell us, hey, our function was fired. It actually did a thing down here, responded with the 200. And if we go back up here, maybe we send it a bad hex code. Maybe we just say, CCCC. You can't have 4. Well, maybe you can. I'm not sure. But let's go 5. If we do that, it says should be a valid hex code. Here's some examples. And we get an error saying the data was malformed. And if we go back to our runner, we see, yeah, we got a 400 response because it's validating some stuff. So immediately we have some things to test, like, does it validate correctly? And also, when we're submitting our form and we get it right, does it properly reset the values so that you can input another favorite hex code? So we have both a front end and a back end thing that we can take a look at. And to start, I'm going to head over here and jump into my Jest test folder. And I stubbed out something so it wouldn't error on me. But we're going to start writing a backend test first. So let me try to run this guy. So I set up a command inside of my package, which I should probably show you just for visibility. This command is going to run Jest in watch mode, and it's going to make sure it's only the changed files. Watch might do this by default, but just making double sure. So we're going to run that Jest, test Jest, Jest test. And when we get that running, we can run all the tests, and we'll immediately get an error here. And what you can see is Jest didn't know how to parse our TypeScript file. And that's because it doesn't support anything other than basic common JS. So if we're trying to do something funky, it recommends checking out, the ECMAScript module setup if we're trying to do that, and the TypeScript setup if we're trying to do that. And if we head over there, we open that up in a little browser, we can see that, yeah, there's a bunch of Babel presets we could install in order to teach Jest how to understand our test files, which is, a little manual setup because TypeScript works on our front end. Why doesn't TypeScript work in test? But we'll go ahead and do this. So if we scroll up here, just making sure we get everything. I believe we want preset env. We also want, let me see here, test Jest core preset env. I'm going to copy all of these and install them in my project. I'm also going to add Babel preset TypeScript. There we go. So this should give us a baseline in order to set up TypeScript. And we'll also need a Babel config to wire all of that up. So I'll make one here. Babel config. I'll head over to my solution on the sidebar here just to make sure I get all of this stuff right. And we'll set up a preset. We'll set up React in a moment, but we're not testing that yet. And we'll set up the TypeScript preset. So once we have the baseline going, we should be able to at least get our test compiling. Once we do that, sure enough, our test pass because we got it running. So now let's actually write some tests, right? So I'm a describe person to describe what a test block is trying to do. I'm going to describe that I'm testing the submit functionality, or maybe I'm testing validation of the submit. And inside of here, I just want to make sure that it errors on empty input. So if I send it nothing, it should tell me, hey, you need to send something. That's invalid. So we have our handler up top, and this is a serverless function that takes in an event, it validates some fields, and if it looks good, it's going to send it back to you with a little message to show on the front end. So in order to send it an empty object, I set up some mocks in order to make this easier. I'm going to say my request is to request from body. So I'm going to send it an empty object, and I'm going to stringify that with this helper. And I'm going to get a response back from the API. And this will be call the handler, wait for it to return. I'm going to send it our request. We're going to send it a mock context. We don't use this, so it's easy to stub out. And also a mock response callback. Again, our function doesn't care about these, so I just stub them out. So TypeScript is happy. So now we have our response. And if we want to validate that it looks correct, we can first off parse the body. Body equals json.parse res.body. And then we can see, it looks like something might go wrong. No problem. We'll make it an empty string. And we can say expect body to have property, I believe, to have property, invalid fields. And this will be our key value store of all of the things that went wrong. So we're just making sure it has that, and sure enough, it does. Also make sure it fails here to see that it doesn't. You also know that it is rebundling all of the tests at the same time, because now that we've offloaded to Babel, it's not smart enough to parse out all of the individual files that change. So it's just going to naively say, yeah, your source directory changed, or yeah, your test files changed. So let me go ahead and rerun a bunch of stuff. But it works. We are able to assert it has invalid fields. And now we could test the success case of it is successful on valid input. And we could test the individual keys and such as well. I would leave that to you as an exercise if you wanted to get a little better with testing. And I will copy all of these fields, these three here, move them down. Cool. And we got a little format thing. So now we have the body again. And instead of sending something invalid, I'll send it a valid name, Ben H, and we'll send it a valid hex code. And this is going to be CCC. And now we have that. Actually, let me do the fun thing. What was it? C dot? Yeah, it's magenta. Look at that. So we're sending a valid hex code, and we're going to expect the body of this result dot status, or yeah, body dot status to be 200. So if everything goes well, we should see a status of 200 come back from this guy. It looks like we are missing something here. Let me double check that I got all of this right. So if I head over to my handler, what fields is it expecting? Favorite hex code, that's the problem. So I'll go ahead and do that, rerun our test, and we are still getting an issue. Let me double check. And I do have a solution that I'll just copy in here if it takes too long. But there we go, status code, that's our issue. So we can insert that the status code is 200, and oh, dang, what's going on here? So it's not in the body, I believe, is the issue. So it's actually just res.statuscode. Res.statuscode. Done. So now we've asserted the true and false cases using pretty standard Jest stuff. If you've used Jest before, this shouldn't be super surprising. But now let's try doing the same thing with Vitest. So if I walk over here, I have a similar submit file set up. And inside of this, I have a stub also. And you'll notice I'm manually importing the same things that I would use in Jest. And that's because Vitest doesn't have these globals by default, but there is a config option in your Vite config that can flip that on if you're into it. But I'm going to leave it off for now and manually import all of this stuff. But the main takeaway here is if I wanted to, I could easily paste in the exact same code from Jest and run it in Vitest as if nothing changed. So we can see here I need describe, it, and expect, and otherwise the rest of my test can be totally unchanged. It uses the exact same APIs as Jest if that's what you're into, including concurrency mode, including parallel runners, all of the features that you're probably looking for. So if I want to run that, I can run Vitest or test Vitest, and if I head over to package, we can see it's a very simple command. It is just Vitest. So if you're trying to run in watch mode, that is the default, and you can use run in order to run it a single time, which is good for CI commands. So I'm just going to run Vitest, and when I run that, it's going to point to that folder, and it's going to pass on all the tests in much the same way. And you'll notice that with what am I thinking of? Jest, I had to set up a Babel config to do all of this. And with Vitest, TypeScript is supported out of the box. There's nothing to configure. You can write your tests with ESM and TypeScript, and you're done. And I can also head over to my config to prove that. The only thing that I've configured is go look in this directory and be a little more verbose because we're demoing something right now. You can turn this off if you want things to be a little bit simpler. And oh boy, logger of undefined. Well, I don't know what's going on there, but I'm going to leave verbose mode on. It might be an issue with it reloading the dev server when I remove that option. I don't know. But yeah, we'll keep it in verbose mode, and we can see that it's going to look inside that directory and run it as you'd expect. And if I edit a file, look at how quickly it's able to reload those changes. Compared to Jest, which has to run everything through a Babel transform all at once, doesn't support TypeScript out of the box, this is able to get things done in almost 100 milliseconds, because it's able to understand your test files. It's able to cache anything that didn't change. Like it was able to cache this submit function because that file didn't change. It was only the test file. And it's going to rerun just that test file since it understands exactly what's going on. So if you're looking for really fast dev server experience, this is going to be the one for you. So now let me jump over to testing something in a front end. Again, we're going to go Jest, Vitest, compare. So for this, I've set up a Jest environment of JS DOM, and that's going to make sure that we can test the window object and other document APIs, since now we're dealing with front end stuff. We're going to use React testing library for this as well. So I'm going to do a similar describe flow, and I'm describing the form reset action. So the only behavior that I really care about is whether or not the form resets when we submit our values or when we submit valid values. So that's a test block that I'm going to make here. And I'm going to go ahead, make a little wrapper for us. And we should have some type inferencing. I'm not sure where that went, but we're going to go with it. So we have our form reset function, and we're going to check that it resets on valid submission. And inside of here, we'll also do this. And this can be synchronous, I believe. It's not doing anything. So we're going to test that it resets. And I've set up a really nice utility here that is going to make sure our form is rendered on the page using React testing library. It's going to get all of the inputs so that we can mock them. And then we get the form back to test what the result is. So let's go ahead and do that. I'm going to get access to the name input, or let's let TypeScript carry us here. So this is going to be that. We're going to await the form setup, import that guy, and this will set up our form for us. And we can assert, the name input. We can check out some other properties in here. Get out of the way. Hex code input and submit button. So we have these at our disposal. I'm going to pull open my test file on the side so I don't waste too much of y'all's time. We're not here to, write a bunch of tests by hand. But the main thing to test is that if you fire an event and we input something into the name box, maybe we want to input into the target a value of Evan Yu. I jokingly said Evan who. If you don't know, Evan Yu is the creator of Vite as well as Vue, a very prolific creator. So if you want to thank someone for Vitest, well, actually not Vitest, but if you want to thank someone for Vite, that's the guy. So we have that, and we're also going to fire something to our hex code input to see what the input of that is. I'm going to use the same. Actually, let me use a different hex code just to be sure. And we're going to wait for an event to come back. So inside of here, I'm going to fire an event. I'm going to click our button now that our form is filled out. And I'm going to expect the value of our name input to be empty. And the same thing should go for our hex code input because it should have been properly reset. And that's everything that we want to assert. So if I run our test file again, we should get a nice little result here, perhaps, or we get an issue going on where we actually got an unexpected token from client utils. That's not the error that I expected. Let me double check here. Oh, of course. Well, we're using TSX now, totally forgot, and we didn't teach Jest how to process TSX. So we have to go back to our Babel config, make sure we have everything. And indeed, we did need preset React, which I had in my starter code. Let's go ahead and install that now. Go ahead and do that. It's a little bit of added friction because our testing library is separate from our front end. So I had to go ahead and install that preset, wire it up, and now if I test Jest again, we should get a at least compiled result. We still have that unexpected token. So let me check that out inside of here. If we go over to our form setup, I'm not sure what's going on with that actually. We find more details over here. Okay, I think I did have something actually for importing our form. And this is the second big thing, assuming this is the issue. In Jest, another thing that doesn't do by default is stub out non-JavaScript resources. Because our form relies on CSS, we also have to set up this crazy thing that I copied out of some config to make sure I understood it. The best I know is that if you're importing a CSS file, it's going to proxy that to kind of a no-op so that it doesn't throw inside of your test. And I left a comment in here. You can check the blog post this talk is based on to better understand that. But all you really need to know is that in Jest, there's a lot of things you have to manually do. CSS is one of them. So I've added that to my config as well. And now I'm going to go ahead and run test Jest. Here we go. Do we still get it? We still do. That is shocking. So we do still have that unexpected token. Let me head back over here. So inside of our form.test, let me see if I've done anything wrong. I don't think so. Ooh, but this comment probably needs to be at the top of the file, doesn't it? So let me move that. And now perhaps, still no. Does anyone in the audience have ideas? Because I am a little bit at a loss right now. I do have a working example over on the side here. So now that I've at least shown you the developer friction of setting up more config here and more config here, we understand what Jest is going to involve. But let me go over to the ready-made example just so we can see something running. But this is how it should look. You know, resets on successful submission. This had a couple extra things added, but you're just going to import the utils and run it. So let me go ahead and run test Jest again and make sure that that guy outputs for us. So I'm going to run that and we see a passed test. There we go. Not sure what was going on there. Your mileage may vary, but as long as you've configured everything, especially the CSS stub that you need to add, you should be able to get the appropriate result. So actually, there is one other thing that our client utils needed to add, and that was mocking the global fetch. And this is something I want to show off as like, if you need to mock a global in either Jest or Vitest, it's going to be a very similar process. But if we head back over to our form, we can see that we're able to use the Jest global in order to mock the fetch call so that when we're testing our form resets, we don't have to do a bunch of extra work. And for a little bit of context, here is that form that I'm talking about. Inside of here, we're making a fetch call to our API. In order to properly test it, we need to mock that fetch call to make sure that everything else passes. So that's how we got the passing result here. But if we do the same thing with Vitest, head over here. I'm going to be saying this a lot, but it really is identical between Jest and Vitest. We're able to use the same form setup. The only difference is that instead of using jest.mock implementation, you use VI, which is Vitest's own name for the global object. So Jest for Jest, VI for Vitest, but everything else remains the same. And if we go ahead and run this test, we can see with Vitest that everything should build about the same with some verbose logs to make sure we're doing the right stuff. And critically, if I head over to editing some of our API or some of our UI that we wrote out, you can see, again, very quick changes in order to rerun our test. It takes about 300 milliseconds, and most of that's React testing library doing its thing. And this is even true if I edit like a component within the component. So whereas Jest would recompile the whole thing top to bottom, when I edit this component, we can see up here, it's just going to rerun based on that component change and leave the rest untouched, perfectly cached. It actually ran quicker this time, even though we're editing a nested dependency. So that's really the beauty of Vitest, is super fast feedback loop with all the APIs that you already love using. So the last thing I want to compare, just to validate, is how our CI flows are going to compare. Like if you switch from Jest to Vitest today and you have a big testing pipeline, how long is it going to take for your PRs to be green? And the answer is about the same time, unfortunately. So if I run it through the process one time, we get a duration of about 1.86 seconds, which is pretty good, but not the best I've seen. If we run the Jest CI through the same thing, we're actually going to get a faster result, 1.386. And through my testing, this holds true pretty much most of the time. I've talked to the maintainers of Vitest around how their test runner works, and it sounds like because Vitest compiles to something else and then compiles back, it is going to take about as long as Jest if you're using a test runner, sometimes longer because of the initial startup time of Vite. So that's one thing I want to call out. It's not a silver bullet. If you want your PRs to go green faster, Vitest is not the answer, sadly. But it is the answer for simplifying the config that you use for your CI where in Jest, we had to stub a bunch of things out and probably stub out more things as our app gets more complex. Vitest was able to keep using the same config we already had. As long as we have the React plugin, we're free to use CSS. We're free to import images as PNGs. Whatever wild stuff that we're doing, it's still going to work in the test runner, no problem. So that's it, really. That's everything I wanted to show off between the two. I'll leave the floor open for questions here if anyone wants to ask them. But otherwise, thank you all so much for coming out and checking out this Vitest demo, and hope you learned a little something.
Ben, thank you so much for your excellent walkthrough and showing all the bits and bobs of testing and the good and the bad and the ugly. One thing I did want to ask you is that, of course, because Jest is so ubiquitous, what would you say are the primary considerations that people should make if they're thinking about migrating to Vitest, but they're unsure about the maturity of it?
Yeah, so I would first say, like, it depends on the framework that you're using to build whatever it is you're testing. Like, if you're coming from Vite already, I would say that because Vitest just reuses your config, it's really like a low bar to make sure, like, oh, if I change Jest to Vitest in my CI and I leave everything else the same, does it run? And if the answer is yes, then yeah, it's probably using all the same plugins for my framework and it's going to stay stable. You don't have to have a separate plugin ecosystem just for test. But if you're trying to bolt Vitest onto Next.js, for example, which has nothing to do with Vite, and Vitest now is this entirely separate pipeline, it might be better to stick with Jest, because Jest is also built for the Webpack crowd. If you're in that crowd already, then Jest has a ton of blog posts dating back years and years. So if you hit a problem, someone probably already found it. But if you're trying to bolt Vitest onto something that isn't Vite, there's less prior art to fall back on if something goes wrong. So that's where I would say wait for 1.0, but you can try it if you want to.
So in your view, it's more for people looking to just create one pipeline with the Vite projects, and then rather than, because you're sort of not solving the issue if you're just sticking with two pipelines by using using Vitest with other types of projects.
Yeah, I mean, it's arguably a simpler pipeline than Jest, where it's like, yeah, you might actually have a separate set of Babel transforms for Jest than you do your project. And it would be cool to delete 50 Babel dependencies for one React plugin. It's like, there's still benefits here if you want to do it. And I will also say Vitest is being used by library maintainers like Svelte, where they are already like, using Vitest internally to test the library itself. So it's got some people behind it. It's definitely got some juice. But in general, yeah, if I'm going to give like the most nuanced answer, probably stick with the incumbent until it's 1.0 and people have more blog posts about it.
And just in terms of the speed, what's what are the main takeaways that people can think about when it just comes to the speed of development and in the way it helps with dev cycles?
Yeah, I would say, as I showed, like, dev servers are where it matters most. And most of the time when you're working with test, you're just trying to make it rerun while you're fixing the problem. And Vitest is just faster. You're going to get a faster feedback loop most of the time. So that's where it really shines. But CI is where it's like, it's just not going to help you that much. So if you're looking for faster production builds, it's not going to get you there, at least right now.
And I know that you can, there's a level of integration with Vitest and Jest itself. What circumstances would you recommend people use that?
Yeah, do you mean like the Vite-Jest plugin? Because I've seen it floating around. Yeah, there was actually another LogRocket post about someone who wired Svelte and Vite-Jest together and then wrote a follow-up post about like, oh yeah, Vitest was simpler. Where you wire up Vite-Jest, you do still have to set up some separate transforms for Jest to understand it, and then you can get going. But even on Jest's own documentation, they admit, jump straight to the shortcomings section of this library because we don't know how much to trust it yet. But they at least include it if you're at all interested in trying it. But if you're on Vite, like, it's going to be more setup, so buckle up a little.
Okay, and then finally, just what's your view of Vitest? Do you see it as a staple going forward? Do you think it will take away some of that sort of market share, as it were, from Jest in the future? Or do you think it will just kind of fill a role, like Jasmine or Mocha or something like that?
Oh yeah, Jasmine. Yeah. Well, I will. One confidence inspiring thing is I wrote this blog post back in February, and all of my advice still holds. Like, I remade the example project from that blog post. And all I had to do was bump up some major versions, and everything kept working. And since it's based on the Jest library, it's like if there's a function in Jest, it's already in Vitest. Like, they're not going to add some fancy stuff that's changing on you as they approach 1.0. It's mostly the internals that are changing to make sure that tests can run as fast as possible. But like user-facing APIs were stable from the beginning and seem pretty stable now. And speaking to the team, there's not many like changes expected there. So I do think 1.0 is pretty close as well. So if you're holding out for the 1.0 release, like, it's pretty safe to try now because you can reuse the stuff that you already have.
All right, good to know. So those who are erring on the side of caution in terms of migrating don't have too much to fear then.
Yeah, I'm a bleeding edge person, so I'll take your angry Twitter DMs if something goes wrong, but I think it is pretty stable right now.
Well, on that note, I think we'll conclude this presentation. Thank you once again, Ben, for coming in today to do this for us. I learned a lot. I'm sure all the people watching this and all of the registrants who will receive a copy of this video will as well. Just a final reminder to everybody that we will be sending this to all registrants, and there will be a link to our YouTube channel where we'll also be hosting this video. Thank you once again to Ben, and thank you for our attendees for tuning in today. Thank you very much.
Yeah, thanks for having me, all.